Hey everyone. So I thought today what we would do is talk a little bit about some of the more advanced lighting options we have in Unity. And up until this point, we've been working with only real-time lighting, so lighting that is changing when we move things around dynamically in our scene. And today we'll talk about baked lighting. And baked lighting allows us to create really beautiful, sophisticated lighting where we can trade off the quality with the performance in ways that we just are not able to do with real-time lighting in Unity. So let's get started. A couple of things to understand here between baked lighting and real-time lighting. So baked lighting is pre-calculated and applied as a light map or a texture to all of the objects in your scene. It's used to render light and shadow. This is fixed. It's done before a player plays the game. And when they play it, they're seeing essentially an image that's being placed on top of all of the game objects. And so it doesn't change over time. This texture is something that we refer to as a light map. Baked lighting will always look better and typically run better than real-time lighting. It's the reason why Unity has a lot of limits on the number of real-time lights that you can have active in one scene at a given time. There are some trade-offs, though, right? So, for example, it may take less processing power for us to be able to run a scene that is well lit using baked lighting. However, we may require more memory to run these games because we're now creating large textures which are used to cover our entire scenes or components of our scenes. We are only going to really use real-time lights in a way which is quite sparingly. We're going to use them only where we absolutely need some changes that are highly visible to a player, and these are connected to dynamic game objects such as our player. Baking a light map really consists of two parts. So it consists of setting game objects in the inspector to be recognized by Unity as static game objects. And it also requires that we have lights set up with a proper mode to render as either baked or mixed lighting. And these are very important because when we have this combination of two things, we can use them to contribute to our scene's light maps. Now, static game objects as a concept in Unity is a little more complex than just making it available to something that works as part of our light map or our baked lighting in our scene. It does a number of things, but essentially it designates that these components are fixed in space. We don't really intend to interact with them in a way where they'll move or their locations will change. And so we can offload a lot of the kind of work that Unity would do in real time to pre-calculations of things. And so this works great for baked lighting because we can understand where our lights are positioned in space, calculate our shadows based on those, and understand that that won't change over time. It will remain the same. And then we leave any kind of changes that might happen in the space to the very few dynamic lightings that we have that we're managing. So to set things as static game objects in Unity, we can simply take the objects that we want to set as static, and in the top right corner of the inspector, click on the static field. And as I mentioned, static as a concept is actually more complex than just working with the lighting system here. If we click on the caret, we can see that it includes a number of things, which we'll continue to dip into as we continue along with Unity. Now, we typically want to do this with just about everything in our space that is not moving. And so I'm going to go ahead and set this up in a way so that I have my room and then also that I have my crates here all set up as static things. And so I'll do this here at this level. And Unity will ask me if I want to change my children. Yes, I do. Right. And so we can see now that individually these are labeled as static as well. I can do this with my lights in the space as well. Right, and I can continue to just go forward like this. Actually, what I'm going to do here, I'm not going to do all of these because I think I'm going to leave these dynamic, right? So I want to leave open the possibility that maybe in time that I might move these spotlights around. These spotlights are just really simple game objects that I've created that they look kind of like little light boxes here. They have some geometry connected to them and then also a spotlight. So what I'm going to do is I'm going to leave these as dynamic things. I don't have any real plans with them right now, but let's see, we'll do this. We'll make these static, no object only. Right now we also have these set up so that they have an area light, which we'll talk about, which is a kind of a special light that we can use with bake lighting scenarios attached to each one of these. But these are essentially just some placeholders here that we're using to create some simple lighting that comes from above. I have directional lighting on right now, right? So you can see that my scene looks just like this. It's got a pretty dramatic shadow being cast here. You can see my dynamic lights are reacting with my crates. What I'm going to do is I'm going to turn this off and we're going to make it really dramatic. And we have a space here only being lit currently by our dynamic lights, and then the ambient light that we have coming from our environment. I do have a couple of additional lights in this space that I'll just point out. So if you're noticing some different colors that are being projected here, I have a point light here just above my player avatar, which is just there to create a little bit of illumination as I'm moving through the space. This is an interior space. It's not well lit. We never really like the feeling of being completely in the dark, so we're going to create a little bit of light here just to kind of add to the, to illuminate the things that we're seeing just slightly. I also have a spotlight here at the front, which is just operating as a kind of flashlight for me as I move through this space. I'm working with a simple first-person camera system that we've been developing in class. It's nothing special. I've made some changes which we'll talk about related to Cinemachine. Currently, we're not using Cinemachine. We're just using a really sort of straightforward basic thing for prototyping. All right, so let's back up here. So we have our player here set up still as a dynamic game object. We have all of our crates set up as static. We have the game objects that are the 3D geometry in our space for our lights set up as static game objects, and then we also have our room set up as well. Right. Excellent. So what we'll do here is let's go ahead and add some overhead light to this space. And so as I mentioned, I have some lights here. They're currently turned off. Let's go ahead and turn these things on one by one. These lights are area lights. So area lights only worked with bake lighting. It's a type of lighting we haven't used until this point because you can see we've been using just the other kinds that work with real-time lighting. But we now have these available to us. They essentially are a rectangular or disc-shaped panel that push light out in one direction. This is similar to our overhead, our directional light, but in this case, it's much more controllable. We can drag the little dots here to change the size of them. We can position them in space. We can flip them around and move them quite easily. But again, they only work with static lighting. So you can see as I'm turning these things on, I'm still not getting any kind of glow or anything like that, right? So I'm not getting any sort of light. The only light in the scene that I have are the dynamic lights, which I mentioned before. And so that's because Unity has not created a light map for us. It has not created the texture for us that we're using to show our pre-calculated lighting. And we do that by going to our lighting panel. And if you don't have this here, you can add it through the menu bar so that you have this accessible. And we can start to make some changes here. Now, by default, all of these things are going to be set up in a good way for you. We're currently using Unity's newest mixed lighting mode, which is this shadow mask mode, which is really wonderful. It allows us to get nice high quality shadows on top of the baked lighting that we've already got. Down below here are Lightmapper settings. We'll spend a lot of time just kind of like working in this space as we're developing things. These are the things which control way our Lightmapper is creating and rendering this texture for us. We can use, if we want, our CPU to progressively create this light map for us in the background. Creating a light map, depending on your computer, can take an incredibly long time, from several minutes to hours potentially, depending on the quality of your direct samples, indirect samples, and all of these things down below. Your light map resolution, the size of your light map, all of these things can actually end up contributing to the time that this takes to run. Now, we do have another option here, right? We have an option to use the preview mode of our progressive GPU, which is what I'm going to do. I found that this is a little less stable. It ends up not crashing Unity or anything like that, but it often results in incomplete bakes for me. And so sometimes I have to kind of like flush things out and then generate the lighting again as I need it, which is fine because I tend to like to choose when I want to generate my lighting rather than having Unity constantly trying to keep up in the background to all of the changes I might be making. And my GPU is much faster here. So your mileage may vary, right? So if you are using a dedicated PC or a PC with a dedicated graphics card to develop your games, then this is a great option for you. It can really cut down the time, but understand that it does come with a little bit of overhead that you might need to do some management. Now, we're going to ignore all of this for the time being. We're simply just going to see what Unity is going to give us out of the box when we generate our light map. And so what I'm going to do is go down all the way to the bottom here, and you can see that I have an option now to either auto-generate things or generate lighting. As I mentioned, I often don't like to use auto-generate. Sometimes I do, but I tend to generate the lighting as I need it. And auto-generate will constantly try to calculate things in the background for you and progressively try to render them at their full quality. I've had sort of mixed experience with how well this works in practice. And so often, again, I like to just simply click on this Generate Lighting button as a way of generating it as I need it. And I should also point out, too, here that we have an option here down below if we decide to, that something doesn't look quite right. We kind of want to we flush out these textures, these images that are being created for us. We can also choose to clear the bake data. And so if anything ever looks kind of weird, that's an option for us as well. So let me hit Generate Lighting. And you can see down below here, it's going to give us a sense of where we are in terms of baking our light map. And we can keep an eye on this space. Unity is not going to stop us from working at this point. We'll keep going. We can keep working on things while this is happening in the background. As I mentioned, because I'm using my GPU, I'm able to have this happen quite quickly. You again may find that this takes potentially several minutes to do. So one thing I would recommend is if you are finding that these bake times are taking an incredibly long time, like make sure that auto generate is turned off, generate lighting as you need them, and then also play around with these numbers here, direct samples and indirect samples. These are going to affect the overall quality of the way light is being reflected from your surfaces. So there is a trade-off here, right? So we're getting kind of a less beautiful result, but we're getting it faster. And so we can also set our light map resolution lower. We can make this light map size smaller. I wouldn't necessarily recommend doing these things unless you actually find that you need to, because once again, we're trying to find a nice balance of like what we ultimately want this to look like, and also how performant it might be. That being said, it doesn't benefit us in any way to wait several minutes to bake lights several times during a development session here. So setting these things lower and then remembering to set them higher when you have a kind of a critical moment where you want to get this out in front of somebody to maybe play test, or you just want to see, keeping track of what these values are for you. It's a great way to really kind of balance that out. And again, if you find you end up with a lot of kind of like weird garbly stuff on the walls here, don't hesitate to go into your generate lighting and clear the bake data, and then just generate the lighting again. It tends to work really well like that. But we can see this is our lighting. Once again, this is all lighting that is happening now in a way that's been pre-calculated. And so I have that's not entirely true. I have some dynamic lights here which make this a little bit misleading, so I can turn these off real quick. That's the other one, and then let's turn this one off. Right? And you can see those shadows have now disappeared. However, let's take a look at this. Notice how the lighting is not behaving. Well, actually, this one is probably behaving pretty well because I do have one more dynamic light in the space. Let's maybe pull this one. This is probably a better example here. I'm trying to find something that is not being influenced by my dynamic lights. Here we go. This is a great example. So notice here that even though I've taken this crate and I've dragged it over here into this area that is clearly being lit from above by blue lights, you can see that there is no influence that's being had on those blue lights on this shape, because this has been pre-calculated, right? We've already decided that this is an object that's not going to move around for us. Any kind of shadows that might be cast as well by these objects, see there's like a little shadow right here. It leaves, you can see the little smear on the ground, the shadow that it's created. Unity's going to leave that stuff there, right? It's being pre-calculated. It's not something that's happening in real time. But again, the trade-off is that our games may perform better in real time. They are also, the lighting, the quality of the lighting is going to be far more beautiful and nuanced than it would be if we were just dealing with real-time lights only. And so what I'm going to do now is I'm just going to hit generate lighting again now that these are in a new place, and we can see how these objects are going to be influenced by the lighting relative to where they are. Right? And you can see here, right, I no longer have a red crate that I'm looking at. I have my regular crate that has some influence here. You can see that they have this sort of nice like blue glow. Yeah, looks good. Excellent. And the reason these don't look bright blue for me right now, even though I have like a blue overhead light, is just the way that this light is mixing. I'm trying to see what I have this set to. I may have it set to kind of a lower value here as well. So I have my intensity, it's set to 1. It's not really low, but it's just the way that these are interacting with one another. And so maybe I'll set the intensity a little bit brighter so we can see if we can influence that just a little bit. And here you notice, this is sort of the thing that I mentioned before. Sometimes we get these weird sort of, incomplete bakes. Things are seem to be a little bit messed up in our bake light maps here. Sometimes we'll get, if things are just kind of too cramped, we have too many objects for the size of the light map that we have, we'll get a warning here about the UVs overlapping. But in this case, it's really a thing that we can simply fix by going to clear bake data and then regenerate that lighting, and then it will flush all of that out for us. Great. Yeah. Still not the strongest, but I can see that I am having some interaction now between this material and the blue light. So that's it for me. If I was really curious, right, I would tweak this around and just make it a color and a material with a kind of quality that's able to pick up that blue light, I think, a little bit better. So I'm going to take this now, and what we're going to do is we're going to turn on our spotlights again, right? Like that, and like that. Right? And once again, we have a combination of things going on. So because we're working with this lighting mode, that's a shadow mask mode, we're able to take these static objects and we're still able to get really beautiful dynamic real-time lights as a result, or shadows as a result. Our player here is, as we move it around the scene, maybe what I'll do is I'll focus this thing like that, and I'll turn off my gizmos so it's a little easier for us to look. And we'll take a look at what happens when we run this. You'll notice too that because my player is a dynamic object, it's not being influenced at all by the baked lighting we have, right? Again, because those lights now only exist as a texture in my space. While we are interacting with our real-time lights. Oh, you know what? I realized one thing here too. I believe that when I set these up, I may have had... Oh, right. So here we're in a good place, right? So I intentionally, I guess, or unintentionally rather, started with a light that makes it very easy for us to work with baked lighting because it's the only option that we get. However, something like this spotlight here, which has this little spot right there. You'll notice that like it's currently set for us to use in real-time mode. We can change this. We could make it so that we also include this in the global illumination calculations that we were doing that build our light map texture. And so to do that, what we want to do is we want to take this light and we're going to set it to either mixed or baked. And again, this really just depends on how you intend to use this. If you intend for this light to continue to interact with the player, but also create sort of beautiful baked lighting and shadows for you, you would want to pick something like mixed. And if you want it simply to work in a way that only is going to contribute to the light map, we would set it to baked. And so we'll start there. Maybe we'll do that with this one. And then with the other one, we will set this one up so that it is mixed, right? And just to remind myself, oh, I've got a crate right over this now. Excellent. Let's put this in the corner here. Great. So this one will be my my mixed, so dynamic and static. And then this one will be my baked or my static light only. So let's see what happens when we bake this. And you can see it doing it in passes, right? Take a look at, the shadow here, as it's developing. You'll notice one thing too, that, by default, our shadows look like quite different than they do from the ones in real time, right? So we have a set of settings under quality that we're using and that we can set with our individual lights that are using real time or mixed lighting to be able to, decide how these shadows are going to be cast dynamically in the space. But here we have a nice soft shadow. We can see also that the shadow from this little cube is picking up and being influenced by the ambient color that we've set up with our red light. How beautiful that is. So it's blending it together. But once again, so the thing is with this is that this is baked into place, right? We're not changing it in real time. We're just setting it up beforehand and then leaving it as it is. And this one, however, you can see, once I move this around, that I have a combination of things, right? So I still have this like shadowy spot right here that where it was baked. I have, let's pull this over here, a nice dramatic shadow that's being cast on the wall currently. You can see I have the influence here of the shape that from where it was initially placed on the wall. So I have a nice combination of things going on. I also have the ability now to still move my dynamic game objects in front of this light and have them illuminated and still cast shadows, right? So I have a combination of things. Whereas in front of this one, I do not. No influence of this light. And you can see even here, no influence of this shadow. So that's the basics of how we can start to work with bake lighting in our scenes. As I mentioned, we have a lot of options here to control the overall quality of things. We can change the number of direct samples and indirect samples that we have, which would influence the overall quality of things. For example, I might set this to something, just to demonstrate, like 8. And let's just clear this just to make sure that I'm getting a really accurate result. Okay. And in my case here, it's not so bad. I have really simple geometry, right? So things might be a little fuzzier, but because I don't have much detail that I'm working with, the results still seem quite okay. They're less less crisp here, I think. So let's try setting that a little bit higher. And honestly, with such a... Oh, now I'm getting a lot of stuff. Again, I'm just going to clear this. This is sort of the pattern I get comfortable with, just sort of going through. And I'm not even sure this is going to have any notable result. Yeah. So in our case here, I mean, things don't look really any different. So, there's not a real benefit to have me setting this number of direct samples so high right now. So these are areas where we can always play around and decide, what ends up being a good trade-off between performance and quality in our game. Same with our maximum light map size. So if I went and took a look at my light map here that I've created for the room, I can see that it's set to 1024 by 1024. I'm not I don't know, maybe I'm using like 40% of this space. If I wanted to, I could try to make this light map fit in a smaller space so that it would occupy less memory when loaded into my game seed. But there's kind of a danger there, right? So here I have such simple geometry that these images that are created as my texture are so so simple, basically, and I'm able to very easily get around like generating just like really simple kind of gradients to be able to map this stuff, or Unity's able to do this for me quite easily. And if I had something that had greater detail in it, I would need to increase the size here, and then also consider changing the size of the light map resolution. So the resolution in which these texels or these textured pixels are, how many are per unit that we're creating here. One other thing I'll say here as well is that often when we start changing these settings around between our light map size, our light map resolution, and also we start changing the way that these samples work, we might find that we end up with some sort of bleed, or we might end up with the UVs of the game objects in our space starting to overlap. And when that happens, we can often overcome some of that by either increasing the size of our light map or by taking the padding and just adding more padding between these things. The other thing that we can do, and sometimes this also contributes to this, is we can go to our scene and we can look at these materials that we have, or excuse me, these game objects that we have, and we can think about the relationship of the player to these things. So what the player is seeing. This space it's quite small, so there's probably not a real large benefit to me doing this, but I can also choose to take this and change the scale of the texels, the units that I have here, and render them at a different size in my light map. So say, for example, right now they are at 20% of this. And if I go up to my full unit and I go back now and I'm going to clear this and then generate it, when it's created now, it's going to take up more room, and it might actually give me a warning now that just says that I have some overlap. No, so far so good. Great. But you can see now we've filled up one light map here, and we've got a second one now that that's being drawn for us as well. And the second one here is, again, relative to the changes that I've made out here in the inspector, right? Because I'm rendering this now at a different scale. And so these are some options for us to be able to kind of weigh out and balance some of these things in terms of their performance. So keep in mind as you're developing your light map here that a lot of things in this area are going to affect how long it takes for us to render, beforehand as developers, the lighting in our scene. Stuff down here is going to affect largely performance for our player. So how much memory is going to be required to hold these textures while the scene is loaded, and so something to keep in mind. One last thing that I want to show you here, just while we're on the topic, this is kind of a nice bonus. So we currently have these lights set up top here, but they're not great lights, right? They're really just sort of really boring kind of standard Unity texture here. They have a light, but it doesn't really feel connected. It doesn't feel like a light source to us. So one thing that we can do, especially if we're working with something that is supposed to appear as a self-illuminating surface, is that we can set these materials as emissive materials, so that are materials that have emissive qualities. And so, for example, if I focus on this one here, I have this color, this light attached to it, and I have which material is connected here. Okay, so I've got this. Good. Oh, excuse me. I'm in my light. I've got my overhead light here. I've got my material here, which is overhead light material 1. So if I went back here, and these are just really basic materials that I've created. I think I've already set these up as emissive just to save a little bit of time. But we can work within our standard Unity shader here, but we can check on this emissive field. And when we do this, we can add a color. I believe I'm in this blue area here. Oops, I need to do that. I think it's just slightly more of like a purplish color, isn't it? Okay, great. And now, so get out of this mode. Now this appears to glow blue. The problem now is because I actually have this set to all of these. Now they're all blue, so it doesn't make much sense. But I can go through and individually address these and make some changes. So now I could say that this one, maybe this is going to use overhead light, this one that I've set up here, right? And you can see right now it already kind of gives us a sense that this is working. Just again, so we can see, it feels more connected to the light in the space, right? So even though this is not, really contributing to the lighting in our scene here, though we can contribute, here by making sure that this is connected this way, we're not going to really be able to meaningfully contribute unless we add some additional light. So I'm going to go through here, and so this one's a red one, area light. Let's change this to, excuse me, my material. Change that to red. Great, and the last one is also red, I think, so we'll change that too. Excellent. Great, and so let's see now how this is working. I think what I'm going to do is I'm also going to take this spotlight that I have here that I set up as baked. I think I'm going to set it so it is once again only real time. I'm going to maybe set the other one in the same. And then I'm going to clear my lighting, my baked data. I'm going to generate that again just because I'm working with my GPU and I can do that nice and quickly. And we can see now, right, because this is just kind of sloppily put together, that the textures, even in like without any kind of illumination whatsoever, were nice and bright in this space. Okay, great. And see, again, the result feels like we have something that's a little more connected. We have something that feels like it is contributing to the light in the space. You can see a little bit of a glow here from this emissive material because of how we have it set up. Good. Looks great. Great. So again, we can get some really nice, beautiful lighting just like this.